Okay, good afternoon, everyone. Welcome back from break. We're ready for our panel discussion. We have all our speakers from today up here to answer any questions which you have. We have a revision of Ravi Chatra is here to represent the National Transportation Safety Board as Robert Hall needed to leave. So feel free to ask any questions to our panelists.
Yeah, I got one. Max Kiba was just up there. But to follow up on some of my questions, so I heard a lot of good comments about the flow chart itself again, and I'm just trying to, I heard comments on issues with the process, the flow chart, but not a lot of detailed or good or consensus solutions, I should say. So again, any thoughts you all have on the flow chart itself, and I kind of like this, but I don't like this part about this particular number part of the flow chart. Just interested. Anyone? Or going back to, we heard the regulations, right? Is maybe the regulations need to be updated, or we have heard in other circles the M2.0, but is there something in subpart E that we can beef up more? We're just not getting there. Again, I talked a little bit about the 195.303 risk-based alternative. Are people using that, not using that, or have they tried it? And I don't know if this is just to the panel, but really anyone in the room. Part of the issue is, my issue is we have these meetings, we get everyone together, and then we say, let's talk, and then we leave for a plane, and then when do we talk again until we get a workshop, and then we say the same thing. So how about 195.303? Any operators that have used that successfully or not? Issues with that? I got.
David Pearson with Colonial Pipeline Company, and the comment about the Max brought up with regard to 303 is, I think the issue is in order for you to have taken the RBA option, you had to select that in 1999, and it was an option versus the hydrostatic test rule, and it came with annual requirements that you had to fulfill. So I think the issue is a lot of people have probably followed it in principle. Kind of goes back to the comments that Jake made with regard to what we have done over the years to utilize ILI technologies. But the issue is that officially you probably haven't been a part of the RBA because you haven't done that adoption of it and you haven't done those annual reporting requirements associated with it. So I think there's some unofficial, you might say, utilization of the RBA process, but not something that somebody can say they've officially documented it in order to have used it through the regulatory process. So I don't know if there's other areas of that.
In the context of the PRCI project, and I apologize if I wasn't clear about it, what we were really interested in and are still interested in is for those operators who did take a hard look at that in 98 and 99 and develop some processes and some data analysis routines, we'd be really interested in taking a look at that. There's no sense in us reinventing the wheel on some things that operators may have solved 15 years ago. Whether it's in practice today or not, there may be some great material there.
So Peter Lidiak with PPIC, point out that, and kind of adding to what Dave said, is that there was a deadline for using this for pre-regulation pipe, and so people aren't going to have used it contemporaneously. So you have to go back in history to what people have done when they use the RBA, because it's not applicable to anything that's been built since then.
Okay, yeah, I think today we we spoke about spike hydrostatic testing, some of the positives and negatives. And would any of the panelists like to address some of the questions that were brought up today on spike hydrostatic testing, or add more to the discussion?
Well, I was trying to recall some of the points that I already made, and then looking at the chart here, if I'm following down from box 2, I've got a pipeline that operates at 21% SMIs, and its legacy, I've got to perform a spike hydro test, is what this is telling me to do. And I guess I would contend that a pipe operating at that low a stress pressure is not going to have fatiguing anomalies, which it would be what you would be using a spike test pressure to identify. So there's a flaw there that I would identify.
I'd like to build on that a little bit in that, and Phil touched on this, spike hydrostatic testing is part of a crack management program, which for operators is distinctly different than MOP establishment. I've been trying all day to resist a shameless plug on API 1176, the crack management RP, but I have to say that, in that it's our hope that things contained in that RP will answer a lot of the questions we saw this morning and some concerns from some of the public stakeholders about, does the industry know what we're doing about crack management? And I think, to reiterate the point, a spike test is a crack management tool. So you have to start, at least in my opinion, you have to start with your understanding of that crack threat, what's causing it, what's its growth mechanism and rate, what's my reassessment interval, what safety factors do I need, and build up a spike test pressure from that. What's the tendency for pressure reversals? You start from all those things, and then you come up with the spike test pressure. It's almost like the last bit in the puzzle.
Yeah, I would support with what Jake just said there. And I think one of the questions that he had on briefly there was spike test is pressure reversals, and what is the impact to the pipe, and maybe defects that are considered stable defects. How do you impact those when you take a pipe and you pressure test it up beyond the specified minimum yield strength? So there's still questions I think that we have to address on just what are the impacts of a spike test.
Yeah, and I think this relates to some of the research which we're funding now through PHMSA on studying ERW seams. That came out of the National Transportation Safety Board recommendations, and there were several phases to that project. I mean, the first phase was study of the ERW failures in the country, and then the next phase was to assess inspection technologies to find these defects, and that includes, hydrostatic testing, spike testing, and different ILI technologies. This is ongoing work that PHMSA is funding through our research program. That's being done by Patel, DNV, and Kiefner, and there's others involved too, where we're looking at the latest ILI tools, because a lot of times these cracks are so small and there's no volume to these. They're very difficult to detect. And the National Transportation Safety Board made that note after several incidents where an ILI tool was run recently and the pipeline failed. The ILI tool failed to find the critical defect which failed. So we are trying to spur on better methods and find better ways to find these critical defects, not just spike hydrostatic testing. But I think, right now, the state of the technology, it appears that, some of these ILI tools may not be there. I don't know if you want to comment more about that, Ravi.
at least I looked at 2 or 3 accidents back to back where ILI was done within few months of the rupture. And one of the contention we had was no one tool may be adequate to ensure the integrity of your pipeline. Maybe you need to use all the tools that are available in your toolbox. Maybe depending solely on hydro can create a pressure reversal situation in some cases. ILI, all it really takes is one crack that you either miss, the tool misses, or the analyst misses. That's going to come and bite you. So we felt that maybe depending on one technique may not be the adequate approach for integrity. And offhand, I know at least 4 accidents back to back, literally within a few months of the ILI, the pipeline ruptured. And when the data was analyzed again after the accident, sure enough, the tool manufacturer and the operator and analyst, they all said, oh yeah, now we can see it. So it really is an issue. So I don't believe any one technique really assures the integrity of your pipeline. And that was one of the reasons for our recommendation, especially the hook cracks. We looked at all the past investigations done by consultants and operators, and really, if I remember correctly, going by my memory, I think some of the reports said, well, the crack initiation was attributed to this crack, meaning the analyst felt this is the one that started, not necessarily proved. So that's hook cracks really are the other issue. I don't think that the tools are there yet to identify each and every crack, hook cracks. Does that address the issue?
Yes.
If I may, and maybe this is a question for the industry folks or even PHMSA, but I know even since the Bellingham incident in 1999, I've been hearing this ongoing argument about hydrostatic testing harming pipe, whether it's either pressure reversals or other problems. And some people say that's been asked and answered and it's not a problem, and other people say there is still an issue there with how you do hydrostatic tests and whether it harms pipe. And I know the public hears both sides of that, and I was wondering if PHMSA has come to a conclusion about this, or if that's part of what the research you're talking about is trying to answer.
PHMSA's got some new research that will be starting soon on pressure testing, looking at that. As far as the back and forth, I haven't, from my work history, I haven't seen where a higher pressure test has harmed the pipe. If the pipe is pipe of a vintage that has a material that should be in service. In other words, what I'm saying is yeah, you can have pressure reversals, but that does not happen very often. I know I keep hearing like it happens all the time, but pressure reversals do not happen very often.
If I could add to that, it may be dependent upon what our definition of harm or damage is. I'm not going to speak to pressure reversals. I'm just stating the fact that when you conduct a pressure test at a high pressure, it's like a big cycle. It's like a big operational cycle, only a real big one. And while that pressure is up there, there can be metal that's tearing. And it might not tear all the way through during the test. That's what I'm calling harm. That is causing my asset to get closer to failure, but not failing. And I'd like to find a better way to identify that threat that might be growing through operational pressure cycles and fix it before it fails that way, as opposed to causing it to get worse.
You know, I would agree with Steve that pressure reversals are not that frequent, but my experience is for certain pipeline systems, they are frequent. And it's a direct correlation to a manufacturer, year, kind of circumstantial situation. And that's why, as a member of industry, we get real nervous when people advocate simple one-size-fits-all solutions, because you're taking tools away from us. You're limiting what we can do. And we think that we need to try to continue to get the flexibility we need to use the tools that apply for the situations that we have.
We had a question that came in from the webcast. Question relates to the relationship between IMP and IVP that has been referenced by a number of presenters. This is from Martin Phillips, Alyeska, but I agree, in Martin's words. Martin agrees IVP is probably a poor acronym to choose. Martin sees IVP as something that should result from constructing a pipeline. An operator has to prove his or her chosen MOP, MEOP. On the other hand, an IMP is a method of insurance that you can still operate at MOP by inspection testing of the pipelines. How does the panel see the difference between the two?
I think that the IMP really supplements your IVP or MOP determination process, because you're going to go through your calculations and your data and your records, and you're going to establish an MOP. But how you integrate the data that you find from your IMP could dictate what level you're going to operate your asset, how frequently you may operate it. You're going to look at your percent SMICE. There's a lot of different details that the IMP really helps drive, from what the tool called, or what test failures you may have had, or what NDE you did in the ditch, that could ultimately change how you feel about where you operate at. So one point is establishing the MOP, but there's also a validation that you're doing through your testing to help you figure out what you have going on with your line, and that could impact where you have your MOP or your discharge pressure set at.
I think that's a pretty spot-on comment about related to original construction. You know, we, at least from the PRCI standpoint, you know, we think of it as a one-time event because of the same similar terms. You know, it's almost like if you could rewind the clock on integrity management regulations to 2000 when they came out, when the concept of baseline assessment was relevant in everybody's mind. You know, that would have been the right time to say a baseline assessment is an integrity assessment and an MOP validation exercise. Then, once you've done that one time and set up specific IMP requirements for that segment, then your integrity management program takes over. And that baseline assessment or the MOP validation assessment gives you those extra special things you might have to do. Kind of like what we suggested in the PRCI project is, hey, you might have to add a little bit to your repair level or your ILI tolerance. So that's how we kind of think of it, is a one-time event that's going to establish any necessary special considerations for your integrity management program.
No more comments. Another question, oh, sorry.
This is Alan Mayberry. I just thought I'd add a comment on that. Since I actually was in the room when we came up with the term integrity verification process, just a little history there. It actually is, we started with a fitness for service. That's really what it is. It's, okay, recognizing that, you know, the situation as operators really don't know as much as probably they should know about their systems, their records gaps, their issues, certainly with how the establishment of MLP or MAOP at the original time was done. So how do we confirm that the asset is you know, fit for service? So it's just another way really to mention or say fitness for service. You're establishing the integrity of the pipeline based on what you know, and then if you don't know it, you go out and get that information. It's a process for doing that. So there. Hope that helps.
So, okay. Just one thing, whatever the name is, in my opinion, doesn't matter. The name is if you've got a pipeline system and you don't have the attributes on the pipe to verify the MOP, whether that's the material records, diameter, wall thickness, grade, seam type, you don't have information on the toughness of the seam, and you do have crack issues or toughness of the pipe for crack issues, whether that's in an HCA or not, is an issue. If you don't have a pressure test, or whether it's the 303 risk-based option, it's an issue. It doesn't matter whether you call it IMP or whether you call it a man landed on the moon. My point is if you go look at the code, and it's been there from day one, when the code came in, if you look at 195.406, 195.106, and then you look at the ones on the pipe properties, you were supposed to have it. There's operators buying facilities from others and not getting any material records. That is just wrong. And so, I hate to hear, well, we can't do this, we can't do that. Well, we shouldn't be putting facilities and keeping them in service without having a program to get those records. That's just the bottom line part of it. And the thing is you may have a leak or a rupture, and I call it location, location, location. You may get by this time because you weren't by a stream, or you weren't by a lake or a major facility, or by a home or a development, and it doesn't, you get away with it. But then you may get something like Marshall, Michigan, and you be in the papers for the next 5 years. It's whatever you want to take risk-wise, but the thing is the code already lays out what you should be doing if you don't have it. It's just that a lot of this is the way PHMSA was looking at it, is trying to get in some new processes like what Jake said in there. When you have a workshop like this, we want to get ideas like we're getting. But we don't want to come out and say, well, you got to do 1 through 5, and PHMSA's made up their mind. That's why we're listening today and everything. But still, the code, to me, is perfectly clear. If you look at the sections I said and look at IMP, of what an operator should be doing. The problem is some haven't been doing it very well.
And we just had another question. What is the definition of legacy pipe in reference to the flow chart? I'll point out we have a note below the flow chart that goes through a number of examples, but does anyone want to expand, perhaps Steve or someone else, on legacy pipe in the context of that note? Legacy pipe, in the context of the flow chart, what's the definition? I pointed out there's a note at the bottom, but...
That's, if you look at the bottom, the note that you're pointing out, Max, is the proposed definition. It's open as far as when we go forward with anything of what it might be. It may be some items in there that shouldn't be. It may be something we need to add. But if we get things on the docket telling us that, we would definitely consider changing it.
Yeah, I might add, looking at some of the comments we've gotten, there were some comments that had issues with a couple of these that we've mentioned on there, that it's kind of indicated it's a problematic construction technique. But
one thing on the flow chart is our main thing is just to get the items that need to be considered, at least what we feel like needs to be considered. Whether the flow chart goes one way versus another, I personally could care less. You're welcome to draw us a different one. It won't hurt my feelings at all. But the key is to get the main points looked at. That's what our goal is. And how it's drawn up on an outline of getting discussion, we could care less. But anything anyone wants to submit for us to consider would definitely be welcome.
we did have one more question come in through the webcast email. What is the definition of inadequate MOP test records? And I guess that's really asking, give us some examples where we've seen inadequate test records. Does either PHMSA or the state have that? Just examples of inadequate MOP test records. Or operators too, where they're just lacking.
You know, I think to Steve's point, I mean, the code is, at least the liquid code is pretty clear and explicit about what you have to have. You know, some of the items like a description of the facility or the elevation plot, you know, those could have a little bit of interpretation, but I think inadequate test records you're missing one piece of that list that you have to have.
Another one just came in. I think this might be for Helen. When will PHMSA implement IVP in the code and the regulations? I think you kind of mentioned that earlier, but do you want to expand on that?
That's to be determined. Right now, we're in the fact-finding stage of just getting input on the process. We have something out for discussion now. Where we go with it will depend on the comments we get, the input, the suggestions. Also depend on some projects that are ongoing. I must say I'm intrigued by the PRCI project, for instance. Certainly we have work going on too, R&D wise, but there's no firm time. You know, I can't say that there's a time schedule currently for going forward on this. So that's kind of where we stand now.
Katie Young, Jayhawk Pipeline out of McPherson, Kansas. This question's for Jason. You mentioned where you were lacking MTRs and you made some cutouts, and I apologize if you mentioned this and I missed it, but how did you determine how many cutouts to make and where to make all of those cutouts?
Sure. What we ended up doing is, first, as you mentioned, we established where we did or did not have MTRs. And then, so part of that list was all those specific vintages. So where do we have differing wall thickness, grade, manufacturer, et cetera. And the criteria was at least one cutout per every 50 miles. And so there was some bounds around if we only had, I think it was 500 feet or so of a specific vintage. We wouldn't necessarily do a cutout just for that, but certainly if we had more than that, the 50-mile limit.
Thank you.
I have a question for PHMSA, if I may. You know, we've heard things, there's been a lot of effort towards more integrity management regulations. I believe I heard that they're in process, something we kind of call an IMP 2.0. I was wondering if you could give us any information on when we could expect to see an NPRM on that. Because I think it's, at least in my mind, relevant to, you know, some of the things we want to do on IVP.
Guess I'll tackle that one. The hazardous liquid rule that we currently are hoping to issue, or it's being deliberated short of issuing, we're hoping to get out before the end of the year, by the end of the year. So that's kind of what we're shooting for. It's been quite a process. It's a very deliberative process, very careful, thoughtful process in vetting the rule. But we want to make sure it's just ready for prime time when it hits the streets. So hopefully by the end of the year is what we're hoping for. Thanks.
David Pearson with Colonial Pipeline again. One thing also kind of goes beyond this whole process, just want to make sure we keep our eyeball on, and that is the permitting process. You know, when you go into some of these ECA processes and you come up with a mitigation that sounds pretty well, but then you get feedback that's going to take you 2 years to get it. We need to keep an eye on that. Hydrostatic testing, I'm wondering, has anybody got any feedback on whether or not the new EPA regulations that are coming out with regard to the delineation of waters of this U.S. and how that might impact some of the application of these repair requirements. And, you know, replacement of pipe, it might be the way you got to go, but just to get permits for replacing a pipe is quite arduous and could take many years.
Oh, just one more that came in this morning. For an operator operating a pipeline at a percent SMICE less than 72, would the process be applicable for operating a pipeline?
Well, if they're using it to operate the pipeline, no. There's already conversion to service type regulations in the code for both liquids and if it was gas for a gas line. So no, you could not use it to operate the pipeline.
Yeah, another thing we discussed today is engineering critical assessment. I mean, I've been involved with API 1104. I've been on the fracture mechanics subcommittee there for probably over a decade. And, that has worked quite successfully for girth welds. That is based on the science of fracture mechanics, where, that committee feels it's a more accurate safety assessment to determine what the critical defect size is, and it's based on actual test data instead of a one-size-fits-all. Where the main body of 1104, the defects that you allow, it doesn't take into account how strong your pipe is, what the percent SMICE you're running at, the toughness. It doesn't take into account all of the stresses that that weld is under. And the science of fracture mechanics is based on essentially the crack driving force versus the crack resistance force. And unfortunately here, we don't have much details in our engineering critical assessment box, but it's intended to be, not a one-size-fits-all, but to get a more accurate picture of what, what the critical defects are, what the critical defect size is, and where if it is that size or above, that will fail. If it's below that, it's safe and it can remain. So, it may minimize, unneeded repairs. And it's not, based on a one-size-fits-all, because I think as Steve pointed out is, some of these, ERW seams, they have much lower toughness than what everyone assumed that they would be. They're less than 20 foot-pounds. And if you were to take that into account, some of the fracture mechanics equations would come back with a much smaller critical defect size. So I guess what I'm trying to say is, engineering critical assessment has been used for many years elsewhere. And I think, once it's developed, once we have a clear-cut plan and procedure on how to get it done, I think, people will be more comfortable with using that method.
Okay, I'm back, and it's time for the wrap-up section of our day today. It's been a little bit of a shy group. Because of you, I've got to go back to the office today. I'm really disappointed in you guys. Gosh, oh my gosh. But if I can read my chicken scratch here, I'll go through some summary comments. But no, just kidding on that. We've had some great dialogue, especially in the afternoon. I think it's good to have a discussion. I know there's some apprehension over something that's presented as a framework. I think, one of the themes I heard, certainly from many of you, was that, you need more detail. And the devil is always in the details. We kind of weigh that when we come to these things. We also are subject to, in walking that fine line, getting criticized if we come with too much detail, because it might look like, well, you guys decided it, and here you are, and we didn't have involvement in it. But so we think we're at the right spot to move forward with trying to fill in some of those details as we go forward. I can assure you, like I started out with, our focus here is getting your input, and as we go forward, we will continue to look and rely on your input, whether you're a vendor, an operator, the public. We do look at the comments that come in, at your input, and we give thoughtful review of that input. Just summarizing, I thought, right up front today, Robert Hall, I thought gave some really relevant points related to, NTSB's experience and observations on failures. Certainly the need to be more investigatory and look for things. Just make a side note on that, regarding being investigatory or looking for things. We do have a risk modeling workshop coming up that's, I call that a sequel to our 2011 risk management workshop. This one's focusing on risk modeling and trying to move the ball forward on doing a better job of modeling risk, moving beyond simplistic risk, index models to being able to really looking at specific threats, identifying specific threats that might be masked by current index models. Also, how do we deal with interactive threats? To that end, it also addresses some of the NTSB items that have been pointed out to us. I'm really looking forward to that workshop because we're also bringing in some outside of the industry speakers to speak to, how it's being done elsewhere, from academia to other government agencies. So that's my little side note on that, to advertise for that. That's September 9th and 10th. I think it'll be actually in this very room here as well, and that will be webcast. Just moving on beyond Carl, we had, beyond Robert Hall, we had Carl certainly, focusing on, the concern of everyone is zero accidents. I think everyone embraces that goal. And certainly related to hazardous liquid IVP meeting that goal, I think there's some pluses and minuses that Carl pointed out to us, certainly on things that were good and maybe things that needed to be looked at because they're kind of a question mark. Probably it's the same with question mark for many of you. The ECA, or as Carl put it, the ECA magic black box. Certainly that's something that, a lot goes into that, and we'll need to continue to discuss that and come up with more meat around the bones of an ECA. And certainly from the operator panel, appreciate the perspective. The easy button was, there is no easy button on this issue, and certainly, it's a challenge in light of the record keeping, the state of record keeping. I know to some of the things we're looking at might seem like a tall order, but I think to many of you, we've heard that a lot of it makes sense. But certainly, the concern over the hydrostatic test is evidenced by the discussion even after the panel. I think I've been hearing that discussion for many years, but as we go forward, I'm sure there'll be some exciting conversation as we zero in on what is a spike test and what constitutes a good spike test and where do you use it. That's part of what we're after. I might add, too, related to what was mentioned about the PRCI project. We're interested in that. We're interested in keeping up with that. So I think it would help inform us and everyone as far as what's good safety practice. So we look forward to engaging on that. We'd look to. I'm not sure we've been invited to that, but we'd look or would welcome the invitation to participate in some of that. Just randomly mentioning in the aftermath of failures. And I think this was mentioned. We often hear, "Well, I just pigged the line." That's one item we hear. The other item is, "Well, I followed all the regulations," and it's a common theme. Those two items, but predictably, probably our answer you can imagine on "I followed the regulation" is that really is the minimum standard. In fact, we call it the minimum standard. It's all about performance, and you need to know your system, have the information you need to operate the system and ensure performance, ensure safety, and protect the public. So that's the focus there. Our desire is to make sure that we put resources where it's most appropriate and adds the most value to ensure safety. That is definitely a focus of all of us. I did hear the blurred line between IM and IVP. We certainly dealt with that at the gas workshop. I think we had some good discussion on defining what the differences were. And to the extent on IM, we are going to, that will be kind of a focus. Risk modeling is kind of a subset of the overall IM program. There'll be a focus at our September workshop. Of course, Rick, who stepped up, he did make some comments about Subpart E in the 195 reg and, maybe a need for some potential changes there. That's kind of a summary of some items that I picked up on. And I look forward to the continued dialogue as we leave here today. One thing I wanted to mention as far as who we've had on the webcast today and how many we've had here. Normally we give you an update on that as we go. Apologize for not doing that. But it's been a very good turnout. We've had about 85, I think, at the peak here. I think the early flight crowd has left right now as it looks. We've lost a few. We, on the webcast, we were as high as 140, so appreciate your participation on the webcast. It's gone between 140 down to 100 at the breaks, maybe in the 80s. And that's reached out, some pretty faraway places from Alaska, Anchorage, Alaska, Alberta, both Edmonton and Calgary. The oil patch, as you might guess, Louisiana and Texas was well represented, Colorado, and of course Iowa. We appreciate your tuning in today for that, and it is a very efficient way to to participate in our webcast, and we appreciate the questions that came in through the webcast. Lastly, I'd like to thank the speakers, for your participation today. I know, like I said, you have a day job. I know we had some effort talking many of you in, twisting your arms to come here, and really, really appreciate it. Jason, Phil, and Jake, very much appreciate your input and value your input and look forward to the continued dialogue. Of course, Carl, our public partner, we always appreciate your input and your challenge to us and to industry. And of course, the NTSB that is our partner in investigating accidents. And of course, our state partner, our closest ally, Joe from Washington State, all the way from Washington State. We also appreciate your input and involvement here today. And I'll look forward, maybe I'll see you at the National NAPSR next week out west, out in Arizona. And then lastly, from PHMSA, Max, you've done a stellar job. Max is the meeting boss. Max is in the back there. Thanks so much for your effort in putting this on and handling all the logistics. I think it went very well. Everything worked like clockwork. In fact, you were too efficient. We're so early, I have to go back to the office. And then Ken Lee, thanks, as our Director of Engineering for leading the effort. Steve Nanny, for carrying the banner on the IVP process and working with many of the stakeholders on that. Of course, the rest of the PHMSA staff who it takes to put this on, thanks very much. Of course, I would be remiss if I didn't mention Kelly Johnson out front and Janice Morgan, who are also work at headquarters office and kind of handle the registration logistics. So I think I about covered everything. Again, I really appreciate the involvement. And look forward to working with you as we go forward. One last thing, as far as timing, I kind of gave you a non-answer on timing, and my answer might ratchet up a little bit better than a non-answer, but it's hard to predict timing of making policy because rulemaking, as you know, can last, easily 4 years, but we will move deliberately. I do expect to continue the dialogue into the next year, and so hopefully maybe into mid next year, we'll have a good idea of where we're going to head on this. So that's kind of where we are right now. We do have a lot of irons in the fire right now related to other policies that we're looking at issuing, regulations and that sort of thing, but we do want to keep advancing the conversation on this, so I'll look to, for us to see some motion next year on it. So, okay, with that, I think we will call it a day and adjourn, and I wish you safe travels back home, wherever that may be, and thanks again. Meeting adjourned.